Good morning. Today we begin Unit 10, which is, again, as I've said many times, a culmination of 7, 8, 9, 10. Unit 10 itself is called liquids, solids, and intermolecular forces. So if you trace back what we've done in 7, 8, 9, 10, in Unit 7, we talked about atomic theory. We talked about quantum mechanics. We talked about the Bohr model. And we kind of reviewed, hopefully, the Dalton model, the Thomson model, and the Rutherford model. So we can see a progression of how we've advanced our understanding of atomic theory. But all along, each one of the models is not wrong. Each one of the models only explains certain things. And so we advanced it. And that was Unit 7. Unit 8, we got into periodic properties. We started really looking at those electrons that were described most carefully in Bohr's model and in the quantum mechanics, even more so in the orbitals. And in Unit 8, we talked about how those valence electrons, really focusing on electron configuration, and those valence electrons really seem to influence a lot of the properties of atoms. How do they react? How do they lose electrons, become ions? All that kind of thing was focused on valence electrons. We got to Unit 9 and we talked about bonding. So now we were looking at how two different atoms, so 7 and 8 were focused on a single atom. 9 is how atoms come together and bond to each other. We talked about molecular geometry. We talked about VSEPR theory, talked about valence bond theory. But really what it was about is the interaction between two different atoms and those electrons of those atoms. We now have a molecule, and we can understand better bond strength, bond order, which really is a made-up sort of thing, but it helps us guide us in understanding bond strength. And we have a molecule. In Unit 10 here, we're going to look at how one molecule will interact with another molecule. And we've done this in one of our labs. We talked about intermolecular forces, but now we're going to look at them in a little more detail. It's all related, though, to those electrons, and you have to keep that in mind. So once again, we started with just a single atom. We looked at the electrons within the atom, subatomic particles. We looked at how atoms interact. And now we're looking at how different molecules will interact with each other. So we've grown into a big picture to look at the entire thing. That's what Unit 10 is these molecules. Because when we did that phase change lab, we saw that if we start with gases, which again was Unit 5, gases, talking about individual atoms, when they come together and they condense, they will form a liquid. Well, condensing really means two particles will somehow become attracted to each other. If we continue that and cool it down even more, or in fact, we can change the pressure, which we'll learn about this chapter or this unit, but if we cool it down even more, a liquid will have stronger attractions or less energy to break those attractions and form a solid. So we're going to study liquids, solids, and what makes molecules into liquids and solids in this unit. In this unit, the assignments you'll have a mastering chemistry assignment, which you should do after you watch the videos. You will have a lab to do. Now, the lab itself isn't related to this unit. It's a review of older stuff, anions, cations, and think really hard when you do that lab about types of chemical reactions. It's going to be a good review for the final exam of types of chemical reactions and what anions and cations truly are. It's a kind of a qual lab, but you'll see what happens in it. But the lab doesn't relate directly to this chapter, to this unit. There's an extra credit opportunity, which you do at the very end. And there will be an exam at the end of the week. Keep in mind, this exam is going to cover units 7, 8, 9, and 10. It's not a computer exam. It's all handwritten or typed or however you want to do it. Do it on your iPad, however you want to do it. But it's something you must print out, and you're going to write on it and then turn it in as an assignment. That'll be available on Thursday and will be due by Sunday at midnight, as will all this work for this week. Now, this exam, as I mentioned before, hopefully is going to encompass all these 7, 8, 9, and 10. So what's going to happen is, if you do better on this exam than you did on the 7, 8 exam, this exam will count twice. In other words, it'll replace the 7 and 8 exam and count for the 9 and 10 exam as well. So between the two, 7, 8, 9, and 10, there are 2 exam scores. It's been a big part of our semester time. So that's why it's worth more points in your grade. But this is going to see how everything fits together. So you really need to see the big picture in this exam, and it'll tie together all those units. Of course, before you begin this exam, you must understand intermolecular forces. And the thing to understand about intermolecular forces, intermolecular forces are different than intramolecular forces. Intramolecular forces, INTRA molecular, is what we learned last chapter. That's bonding. That's what holds 2 atoms together into, or intra means within, into a molecule. Intermolecular, INTER, is the attraction between 2 completed molecules or particles. So you have to understand these intermolecular forces, which still rely on, as we saw a while ago, polarity of the bonds, possibly the ionic character of the bonds. We have to understand these molecular forces, but these intermolecular forces, and just as we focused on the strength of intramolecular bonds last chapter, we need to focus on the strength of intermolecular attractions. Now be careful, because they're not always called bonds. The wording is kind of weird, but these intermolecular attractions can be stronger or weaker, which will be reflected in the boiling point and the melting point comparatively, stuff like that. Again, we saw that in that change of state, or the states of matter lab we did. But you have to focus on, it's a commending from actually no attraction to a very strong attraction. And although we label different attractions along the way, it's really a spectrum of these different attractions. You need to start trying to figure out or appreciate why those attractions might be stronger or weaker, what causes those attractions. And that's what this unit is about. So once again, this unit is fairly, there aren't a lot of videos, but they're kind of dense. So you really need to visualize this and see this. And go back, and before you take the exam, take a look at 7, 8, 9, and 10, and see if you can figure out, see if you get a picture in your head, not figure out, but see if you can get a picture in your head of how these things all fit together to influence and create the final product. After this week, we'll have, this is our last unit exam this week. We will have another unit next week, and then is the final exam. Well, we'll talk about this next week, but I will have some review material for the final exam available to you. But once again, hopefully you reviewed for the final last week with a little spare time, and start looking at those objectives. In addition, if you complete any work that you have not completed earlier in the semester, in other words, late work, but you've completed it now, I really want you to complete it. It's very important, because this is about learning. And if you don't do the work, in my mind, you don't learn. So complete the work. But if I already have a grade in the grade book for something that you then go and complete, you need to send me an email letting me know to take a look at it. I won't know to look at it otherwise. So if you have a grade and you do some more work on something, or you finish something, make sure you send me an email telling me directly what it is you finished, so I can go back and take a look at it and regrade it, or grade it, I guess. Okay, so that's that for this week. Does anyone have any quick questions? Okay, then I emphasize again, we need to be able to see how all these things work together to create our macro stuff we see. What creates big products? How do molecules attract to each other? What about atoms make that happen? That's the goal of this week, to tie those 4 units together. If you have any questions, please let me know. And if I don't talk to you sooner, I will talk to you next Monday.